The shape of a finished component and the material from which it's manufactured can be a very limiting factor when it comes to the method you're going to use to produce it. Casting metal to a specific shape or forging it from hot billets are just two examples where the function and the performance of the component almost dictate the production technique. Cost is, to some extent, of secondary importance. But there are many components which can be made easily and cheaply from sheet metal. All sorts of motor car parts. Domestic appliances like washing machines, fridges, radiators. Anything really, from tin cans to metal baths. All can be made by press working. If the pressing process hadn't been perfected, a lot of these things would be extremely difficult to make and extremely expensive. Objects produced from presses are uniform and highly accurate, each piece identical to the one before it and the one after. It's a technique which gives production engineers a great deal of flexibility, and it's ideal for mass production. By and large, finishes are smooth, the pressing can have considerable strength and rigidity, and you don't waste too much raw material. Most press operations demand specific tooling. Tooling up is an expensive operation, and you can only do it if you're going to produce enormous quantities of a particular object. The most popular metal when it comes to pressing is mild steel. It's still fairly cheap, and so far seems to have the edge on aluminium and plastics, except for certain specialized functions. In this program, we'll be looking at the pressing opportunities offered by mild steel. But the techniques apply to other materials as well. The key to successful press working lies in the press tools themselves. This is a simple tooling setup. The top half of the tool is called a punch. At the base there's the bolster, which supports the die. This will reflect the shape of the pressing, and it's usually made from a hard-wearing material like a hardened alloy steel. The other half of the tool, the punch, is moved usually downwards to punch out the component from the metal strip. The punch in this case is attached to the ram of the press by the punch plate or holder. The cutting out of the metal shape from the strip is called blanking. The strip is brought in as cold-rolled coil. It's a convenient way of providing a large quantity of material in the smallest possible package. The strip is passed through a set of straightening rolls to this simple single-action power press, which punches out a series of circular blanks. Blanking these out one at a time from a single piece of strip would be wasteful and uneconomic. So they've increased the width of the strip by 1/2, and so doubled the number of blanks obtained from a given area. The whole idea of a blanking layout, and hence the layout of the die, is to secure the maximum number of blanks from the minimum amount of metal. You can see there's very little waste left here. One drawback when you press a blank is that you can get burring of the edges. If the piece has to perform a precise and delicate roll, as this car seat adjuster mechanism has to, then you'd have to deburr each component after it's been blanked, and that would be time-consuming and cost a lot of money. Quite recent.